Uh, yeah, grade 8, let's look at some revision for term 2. We shall be looking at what we call exponents. What I want you to remember, or what I want you to know, exponents, another word for exponents, we call them powers. What are powers? Powers are these numbers that are on top of another number. Powers are the numbers on top of other numbers. In other words, for example, we shall have a number, or let's first look at the part of, we have what we call, let's have A to the power of B. So in this case, our A is what we call the base, and the B is known as an exponent, or we shall call it power. You understand? So in this other case here, it's A. A is to the power of B. All right. So now let's take another example. What about if it was 7 to the power 3? So here in this case, 7 is the base, and the 3 is the power. All right. You might call it the power, or you might call it the exponent. You might call it the exponent. Those are, sorry, this is the introduction or what you have to know. All right, we have some rules that we're going to look at. And these rules are around they're around 3 to 4 or 3 to 5, right? Definitely you have to have rule 1, rule 2, rule 3, rule 4, and rule number 5. The main ones are rule number 1, exponent rule or exponential rules or rules of exponents or laws. Okay, rule number 1 or law number 1. Rule number 1 is called the product rule. Together, the product rule. The moment you hear the word product, this comes from it's a multiply or multiplication. This is the answer that you get after multiplication. Then when you hear product, what I want you to remember, it's add. What are you going to add? We shall add the powers. When does it work? All right? When does it work? When you multiply values or same bases. If you have the same bases, then you add the powers. We shall do an example right now. Add the powers. What do I mean by that? Add the powers. Example, we have x to the power 3 times x to the power 4. These are the same bases, but different powers. So what will happen? It will be x3 plus 4. Why am I adding? Because I have multiplied same bases with different powers. So here, our final answer will become x to the power 7. So this is where the law of product or the one for multiplication comes in. If you multiply same bases with different powers, you add the powers. That's rule number 1. Okay. Let's look at rule number. Okay, another example for rule number 1. We are saying another example. It could be 2y to the power 2. Multiply. We are looking at product. Multiplied by 3y to the power 4. Guess what's going to happen? The numbers will multiply themselves, which is 2 times 3, get a 6. Then, what are remaining with? They remain with y. But these y's are 2. We have here and there. But you're multiplying them. Simply meaning, we are going to add the powers. So here the final answer becomes 6y to the power 6. Where does the 6 come from? We are adding 2 plus 4. And we get that answer there. All right, let's look at possible questions here. First and foremost, we shall look at what we call the expansion. Okay, here we say, now, write down the following in exponential form, meaning they want you to write the answers in power form. So, let's look at the solution for 1.1.1. We have 3. So it's 3 throughout. So meaning the base is going to be 3. But how many times does it appear? We have 1, 2, 3, 4, 5, 6. So meaning our answer here is supposed to be 3 to the power 6. This is the exponential form. Let's look at 1.1.2. 1.1.2. What do we have? We have -4. Wow, it's -4. But how many times does it appear? Yeah, 1, 2, 3, 4. So -4 to the power 4. The reason why I'm stopping it is because they say in exponential form. So this is what they need you to do. 1.1.3. 1.1.3, we have what? A throughout. But how many times does it appear? We have 1, 2, 3, 4. So A is to the power 4. That's what they want us to have. So let's look at 1.1.4. We have throughout, we have negative b. So it's negative b to the power 1, 2, 3. So our answer equals to that. All right. What I forgot to tell you, but you will learn, this is revision. Should a negative number be powered by an even number, your answer should always be positive. And then a negative number powered by an odd number, the answer will always be negative. Take note of that. Okay. That's how we express, that's how we do the exponential form. Okay, we look at the other one. They are telling us to expand and calculate. Now, expand and calculate meaning we need to have a final answer. So, expanding. When we look at 1.2.2, we have 7 to the power 3. When we expand this, that means 7 is multiplying itself 3 times. 7 multiplying itself 3 times, which is 7 times 7 times 7, which is approximately 7 times 7 times 7, which is 49 times 7. And the answer becomes 343. This is what they wanted you to do. We look at 1.2.2. We have, this is what I was talking about. We have a negative number, but it's to the power an even number. Definitely the answer is going to be positive, which is -5 times -5, which is a negative times a negative, you get a positive. Here we have the answers, 25. Okay, 1.2.3, this is where we are. We have a negative number to the power an odd number. This is going to give you a negative number. Why? It's a -3 times a -3 times a -3. So, first and foremost, these are the first two are going to give you a +9 times a -3, which gives you -27. You can put it in your calculator and you find out. These are great. Grade 8, you're allowed to use your calculators. All right. Let's look at 1.2.4. Still, we have a negative number to the power an odd number, which is 5. Meaning, -2 is going to multiply itself 5 times. -2 is multiplying itself 5 times. So I'm here looking at this, I see it as -2, this is 4 times another +4 times a -2. So here we get positive 16 times negative 2. The answer becomes negative 32. And when you put it in your calculator, I believe you have the answer as, don't forget to put them in brackets. What do I mean by that? Listen to one thing. This is my calculator here. I have a negative 5. Negative 5. Sorry, negative 2 to the power. The power that you use here, it's this x here, 5. So I press my equals. You see that? You should do this to confirm your answers. So we have a negative 32. Okay, we look at question number 1.2, 1.2.5. 1.2.5, we are dealing with exponents and laws of exponents. So we have a 2 to the power 3 times bracket negative 1 to the power 3. What do we do first? Let's expand, which simply means it's 2 times 2 times 2 times negative 1 times negative 1 times negative 1. Okay, let's continue. This is when you multiply all this, you'll end up having positive 8 times negative 1. So my answer here becomes negative 8. Negative 8. Negative 8. You can confirm that using your calculators there. We shall say 2 to the power of 3 times, you press that, times, open brackets, negative 1 to the power negative 3. We end up having our answer as negative 8. Please only use your calculator to confirm. Use your calculator to confirm. If they ask for working, please, we need to see this. We need to see that you've expanded and you have calculated. Okay, we look at question number 1.2.6. 1.2.6, I will write it up here. 1.2.6. Guess what it wants us to do? Expand and calculate. Okay, how do we expand? So this is negative 4 times negative 4. I'm doing this question here. So plus negative 2 times negative 2 times negative 2 times negative 2. Why is it 4 times? Because it's to the power 4. Now, at this moment in time, here we know we're going to get a positive answer, which is 16. Don't forget, we are adding. We are adding. Then negative 2 to the power 4. You get a positive 16. Negative 2 to the power, you get a negative. So here the answer also became 32. All right. How will the teacher mark this? First and foremost, have you expanded? Did you analyze the answer? You know, expand, get your final answer. Expansion here, do you have the right answer there? Analyze that. Did you expand? This 1 mark for expansion. Then, did you get the final answer? Did you simplify? You know, this is how we do our numbers. Expand, simplify, get your final answer. Expand, simplify, get your final answer. All right, then we look at another function here. This is when the law of multiplication comes in. The product, rule number 1. This is what we are using. Rule number 1, the product rule. The product rule. If you multiply numbers of the same base, what we do? We add the powers. So here we are looking at the product. Let's look at the product rule, which simply means multiply the same bases, add the powers. Let's look at 2.1. 2.1, 2 to the power 3 times 2 to the power 5. this will be the same as 2 because 2, these are the bases. Then we shall add the powers. So here becomes 2 to the power 8. 2 to the power 8. That's the answer there. Then what answer do you end up having if it's 2 to the power 8? You have your answer as 200, 256. Okay, 2.1. Oh, sorry, 2.2. Yes, we have 4 here. But 4 is multiplying with another 4, multiplying with another 4. So how many powers so any number to the power nothing, there's always what? A 1. Any number to the power 0, it gives you 1. Any number to the power nothing, there's an imaginary 1. So our 2.2, it's 4 to the power 3. We are going to add the other 4, the power here. Now I'm adding the powers only, plus 1. So my final answer here has to be 4 to the power 8, which will give me 4 to the power 8. It gives me 65,536. Please put this in your calculator. Okay, 2.3. What do I have? I have a to the power 4 times a to the power 4. I'm right here. This is what we're looking at. So meaning it's 4 plus 7. Why am I adding? Because I'm multiplying. So this will be a to the power 11. That's your final answer. Okay. Then we come to 2.4. I have my base as x. The base is x, but the powers are 2 and 5. So my final answer will be x to the power 7. Okay, this marks the end of rule number 1, which is product. These are the examples of product rule. Okay, we look at rule number 2. Oh, sorry. Also, this one also deals with product. Let's look at it. Now, this one has gone ahead and it has numbers and letters or alphabets. Okay, how do you deal with 3.1? What will you do? The numbers will multiply themselves, and we continue with the base, which is a to the power 4 plus 7. So 2 times 2 times 3, you get 6. A remains, and the answer becomes that much. That's our answer there. Then we have 3.2. 3.2, what do we have? For numbers, numbers will multiply themselves, which is 20 times, what's our alphabet here? X, but to the power 2 plus 5. So here this is 20 x to the power 7. This is your final answer. 3.3. 3.3, this is a question that we are dealing with. 3.3 is the same as 3 with this 3 here times -5. -5. Then, okay, times the y. The y appears twice. So this is the base and this is the base. So which is 2 plus 3. Then times the c. The c appears once, so it remains the way it is. So negative, at negative number times a positive, you get a negative, which is -15. X, negative, there's no x, sorry. This is multiplication. So -15, y to the power 5, c 3. This is the final answer. Okay, we look at 3.4. 3.4, which is this one here. We have 6 multiplying with a 7. Then what do we see common here? We have x and x here. So times x to the power 4 plus 2. Why am I adding? I have the same bases with the different powers. That's why I'm adding them. Then I don't have any y. So it will be times y to the power 3. Leave it like that. 6 times 7, you get a 42. Then x, we add these 2, we get a 6. And my y will become that much. So that is my answer there. That is my answer there. I look at 3.5. Let's look at 3.5. 3.5, it wants us to simplify that. We have any bases that are the same? Yes, A and B. So meaning A squared plus a 3 and B squared plus a 4. So this is A to the power 5, B to the power 6. That's my answer there. Then we go to 3.6. 3.6. 3.6. 3.6, it has 3p squared q to the power 5 times 4p cubed q to the power 4. So what we do, numbers multiply each other, so which is 3 times 4. Then we have times p, because we have a p here to the power 2 and another p here to the power 3. We shall add the powers, the p remains. Then times, what do I multiply? I'm looking at q to the power 5 plus 4. So in other words, here I have 12 p to the power 5 and q to the power 9. This end marks the end of our question.